The first section we'll cover in this course is called Variables, Distributions, and Graphs. Recall, statistics is the science of learning from data, and there are two main branches of statistics. They are descriptive stats and data exploration, and inferential statistics. It's time for us to learn how to describe and explore data. So the material covered in these slides, we'll talk about individuals, cases, experimental units. All of those three words can be used interchangeably. And we'll discuss what it means to be a variable. We'll talk about the two main types of data, categorical data and quantitative data. Quantitative data can be either discrete or continuous. We'll talk about distributions. We'll talk about graphical representations of data, and we'll talk about how to describe quantitative data in terms of its shape, center, and spread. The material in these slides comes from modules 1, 4, 5, and 6 in your textbook. The structure of data. All data sets consist of information about individuals or cases or experimental units organized into variables. So your individuals, cases, or experimental units, whatever they're called, are the objects described by the set of data. It could be human beings, but it could also be animals, schools, states in the United States, etc. And the experimental units are usually along the rows of a spreadsheet. A variable is any characteristic of an individual, and a variable can take on different values for different individuals. Variables are usually in the columns of a spreadsheet. So there are two main types of variables. We have qualitative. Qualitative could also be called categorical variables. And we have quantitative, also sometimes referred to as numerical data, or variables, I'm sorry. And the quantitative variables can be split into two categories. They could either be discrete or they could be continuous. The types of variables you have will determine the graphical and numerical summaries you can use to describe the variables and the statistical methods you can use. So a variable is qualitative or categorical if it places an individual into one of several groups or categories. So for example, consider the students enrolled in Math 171 this semester. Possible categorical variables we could measure on each of them and their values are their gender. Gender takes the individuals, so the individuals in this case are the students, and splits them into two categories, male or female. That's an example of a categorical variable. Class ranking, freshman, sophomore, junior, senior, graduate student, other. That is also taking the students in Math 171 and putting them into different categories. So class ranking is a categorical variable. Also something like whether the student approves of the job the president is doing. Approve, disapprove, and unsure would be our categories. So president approval rate would be a qualitative or categorical variable. A variable is quantitative if it takes a numerical value for which arithmetic operations such as adding and averaging make sense. Quantitative variables usually have a unit of measurement, i.e. time in seconds, height in inches, number of siblings, etc. And we've mentioned how quantitative variables can take on two forms. They can be either discrete or they could be continuous. So if the variable is discrete quantitative, as a rule of thumb, these variables have values that are whole numbers, but do not have values between the numbers. For example, number of siblings. You could have no siblings, you could have one sibling, 2, 3. but you couldn't have 1.2 siblings, for example. So anytime your values are represented by whole numbers, they are discrete quantitative. A variable is continuous and quantitative. As a rule of thumb, these variables have values that can be whole numbers, but also anything in between. For example, the time in seconds to run a 100-meter dash. The current men's world record is 9.58 seconds by Usain Bolt in 2009, and the current women's record is 10.49 seconds by Florence Griffith Joyner in 1988. So these times can be measured by decimal values. So those are continuous. We could have any time between 9 seconds and 10 seconds, any decimal value there. So we have a continuous measurement of time. For this class, you completed a survey. Hopefully you've done that already. This information, we can refer to it as raw data because we haven't made any conclusions about it yet. This raw data was recorded in a spreadsheet that looks like something on the next slide. We want to identify the individuals or cases in this data set, what variables we have recorded on these individuals, and the type of each variable. So here's an example of the spreadsheet. I'm sorry my face covers up some of the last entries down here in the table, but we can see the categories across the top. Again, I think my screen cuts off the very top here, but the individuals or the experimental units in this case are you guys. You guys are listed along each row. Remember that survey was anonymous, so we don't have names here. We're identifying the students with an ID number. So this would be student 1, student 2, student 3, and so on. So each row is representing an individual in this study. The columns are our variables, and we want to decide whether each of these columns is a qualitative or categorical variable or a quantitative or numerical variable. And if it's quantitative, we want to decide if it's discrete or if it's continuous. So I know that's a lot. But here we have, just on this slide, if you have printed the slides and you want to play along, try not to cheat. These are the values we're trying to fill in. So let's try and identify the categorical variables first. All right, so which of these are categorical? Remember, we want to take the students and place them in a category. So gender, student is male or female. That's a category. So gender is a categorical variable. Class. Class is a categorical variable. We can put the students as freshmen, sophomores, juniors, and seniors into those categories. So class is a categorical variable. Whether or not the student lives on campus, yes or no. Those are our two categories. So living on campus would be a categorical variable. Number of Facebook friends, these give us a numerical value, so this is not a categorical variable. This liberal versus conservative rank, again, gives us a number, so it would not be a categorical variable. But party affiliation, Republican, Democrat, I think green was an option, libertarian, other, those are our categories. So party affiliation is a categorical variable. Finally, the number of tattoos and weight, both of those are numerical values, but presidential approval rating, these put us into categories unsure, disapprove, or approve. So presidential approval would be a categorical variable. Lovely. So hopefully we have all of the categorical variables. And as you're watching this video, I hope you can pause because I'm going quite fast, but you can pause and take the time you need to think through these problems because you'll have homework associated with these when the video is complete. All right, so Let's take a look at let's just go ahead and take a look. We said gender, class ranking, living on campus or not, party affiliation, and president approval are all categorical variables. The quantitative variables are the ones that have numbers associated. So number of Facebook friends, number of tattoos, and weight are all quantitative. Number of Facebook friends and number of tattoos are discrete quantitative because you can't have 500 and a half Facebook friends. You either have 500 Facebook friends or you have 501 Facebook friends. You can't have a decimal value there. Number of tattoos, if we are just talking about number of completed tattoos on your body, would also be a discrete quantitative variable. Either you have 0 tattoos, 1 tattoo, 2 tattoos, so on. Weight, though, you can have a decimal weight. You could be 140.5 pounds. So because we can be values in between whole numbers, weight would be a continuous quantitative variable. And then we have a special variable. A couple of those were kind of categorical and kind of numerical because we took something categorical and associated a number to it. So this could be, these rankings on a scale from 1 to 10 could be considered either type depending on the application. So the liberal versus conservative ranking, 1 being very liberal to 10 being very conservative, if we use the numbers, it would be a quantitative variable. Or we could say very liberal, somewhat liberal, moderate, somewhat conservative, very conservative. We could treat each of those things as categories and think about filtering the class into categories, in which case it would be a categorical variable. This is an example of a Likert scale, which we'll see a lot this semester. There are also different types of data sets. A univariate data set is one in which one variable is measured on a single experimental unit. So taking a look at a student and their class rank, one variable associated with an experimental unit. Bivariate data considers 2 variables, whether a student lives on campus and what their class ranking is. If there are 2 variables that we're measuring, that would be bivariate, bi meaning 2. Or we could have multivariate data, considering more than 2 variables measured on a single experimental unit. Math 171, our data sets will either be univariate or bivariate. If you take more statistics past this course, you could get into multivariate data, but I do want you to be able to recognize each of these types. So let's look at a scenario. The 2008 Grape Crush report for California gave the following information on grape production for each of 4 different types of grapes. So we have red wine grapes, white wine grapes, raisin grapes, and table grapes, and how many tons of each were produced. Is this set univariate, bivariate, or multivariate? Well, our experimental unit here are grapes. Grapes is what we're looking at. We have them in different categories, red, white, raisin, and table. And we have a numerical value associated with each. So we have a categorical variable and a numerical variable. That's bivariate, 2 variables being measured on the grapes. So now it's your turn. You have some WebAssign questions to try. Log into WebAssign and using these slides, try homework questions 1 through 8. Be careful though. If there are 2 answer choices, you will have only 1 attempt to answer the question. If there are 3 or 4 answer choices, you will have 2 attempts. And if the question is fill in the blank, you will have 5 attempts to answer the question correctly. So before you use your final attempt, make sure you ask me if you have any questions so that I can help you get the highest score possible.